BYP explaining why we can't go get modern ladder filters and put them in the Drake TR3 in particular, and the TR4. The 3 and 4 filters are somewhat a different design. The 4 filter is more narrow, it's better, but they both work on the same principle. The idea behind a modern filter is that it's a ladder network. If you see Radio Engineer's Handbook, in the chapter on networks, Terman says that a ladder network absolutely must be terminated in resistances. Must have resistive terminations, no reactance. If either port is reactive, there's a lot of loss in the network. Network theory, in general, did not exist until about the 1970s, because to go beyond an L or a pi network to get bandpass filters with complex characteristics required computer analysis. In the 1930s, where these Drake filters came from, and yes, they were made, the TR3 was made in the 60s, but the filter design is from the 1930s, and it's based on something called impedance inversion. Here's a partial schematic of the TR4 filter, one half of it. There are components missing here. There's a transformer, a capacitor, and 2 crystals missing, but this shows a basic point. The filter works by having a transformer winding coming in. This node is reactive, not resistive. The 2 crystals are on different frequencies, separated by maybe a kc or whatever. When they're separated in frequency, there's no point where they're both resonant. So there's no passing a signal through here because the crystals are resonant. What happens is that at a low frequency, for example, this crystal appears capacitive, and this crystal appears inductive. Correction, when the frequency is not low, but when the frequency is between the series resonant frequency of these 2 crystals. When the frequency is in between, one looks capacitive, one looks inductive. If the crystals are chosen such that their magnitude of reactance is about the same as frequency changes between their resonant frequencies, then these 2 tend to tune out and leave that. That's called an impedance inversion capacitor. And this circuit comes from a 1930s patent on the earliest attempts at crystal filters, known as the neutralized design. Similar word and concept to neutralizing an amplifier. But none of this down here is ladder network. That didn't exist until computers, and that's basically after the TR4. If we buy a modern ladder network filter, then if it is a ladder network, then its ports expect to see a resistive termination, and plugging such a filter in this radio will result in a gross failure. Yeah, there's a ham that said he plugged in a modern ladder filter and a Drake TR3, and I posted a link to his video on my previous video on filter design. But in his video, if I remember correctly, he shows a marker oscillator operating at an S9 level. That's right in the middle of the scale. Well, that works, doesn't it? It doesn't work worth a crap. Because here's what a proper filter does. 40 over S9. The proper filter that I made using absolutely state-of-the-art filter crystals, and never try to build a filter with oscillator crystals. The HC49 oscillator crystals can be as high as 60 ohms series resistance, and that's huge losses. There's more power lost than transferred. But this is the stock marker oscillator crystal on 40 meters, just a shade under 40 over S9. That is, I don't know, 60 dB difference. So putting in the wrong kind of filter results in horrible losses. which is going to result in weak receive and very poor transmitter power output because the carrier going into the mixer is too weak. And the mixer output depends on the signals, the amplitude of the signals coming in. I have, and as far as I know, I'm the only person on the face of the earth or company. I'm a person, not a company. But as far as I know, and I spent years looking, nobody has filter crystals for these radios because they're at 9 megahertz. And there's essentially nothing made at 9 megahertz these days. You can buy oscillator crystals at 9 megahertz, but don't try to build a filter with them because they're too lossy. I had to order very special crystals from an original manufacturer that had a few that I tested had between 6 and 9 ohms resistance, which is extremely low. So if you've got a Drake TR3 or TR4, you're not going to find a filter to buy that I know of. As far as I know, nobody sells them. And don't try to put the TR4 filter in a TR3. Don't expect just to plug it in and have it work, if you can even find one. And don't get an old one. There's a very great chance it's bad. But I have brand new filter crystals. If you need some to rebuild a filter, it ain't rocket science. It's difficult getting the TR4 filters apart because they're soldered together in cans. But I have brand new state-of-the-art crystals to rebuild these filters. And these radios are worthless with the original filters because it's almost guaranteed that they're bad. So don't fall for the popular meme of putting a ladder filter in these radios. Don't waste your time and money. Kate BYP.